Okay, so today we're looking at operations on the complex plane. So our learning intention is to gain the knowledge of what occurs to a complex number when represented onto the complex plane. We'll be successful if we can describe and explain what happens when two complex numbers are multiplied together, when the two complex numbers are divided from each other, or when we times a complex number by I, which we've kind of done before. Okay. So there's many ways to obviously represent the complex numbers. We're going to do it in argument form. So if Z1 is R1 cos theta plus I sine theta, and Z2 is R2 cos 2 theta plus sine 2 theta, yeah, then the product is R1 times R2 cos theta plus theta 2 plus I sine theta plus theta 2. So graphically what's happening is where the product of the two complex vectors will have a magnitude, of multiplying the magnitudes together, so the lengths increase, and the argument is as a sum, and what happens is the angle increases and moves anti-clockwise. So let's do an example. So let's Z1 be 3 plus I. So I did that in the blue, so 3 across and then 1 up. And Z2 be 2 plus 2i, so 2 across and 2 up. So I've calculated the modulus of each one, and I calculated the argument. At the moment I'm doing degree mode, so I don't really like. Obviously we could do this in radians, but just for the example, for simplicity, I just made it in degrees. So I times Z1, Z2 together, and I get this new product. I get Z1, Z2 is 4 plus 8i. So the modulus obviously is 4 squared plus 8 squared, 64 plus 16, we get square root 80. And the argument is going to be, sorry, I should say Z1, Z2 here, is 8 over 4, so shift tan 8 on 4, which is 2, I get 63 degrees and 26 minutes. Alright, now let's just check. If I multiply these two things, I get negative 10 times negative 8 is negative 80, so that's correct. And if I add the two arguments together, 18 plus 45, I do get 63. Yeah. So what ends up happening is so negative 80 is 8.9. Okay. 63 degrees is approximately here. I lost my ruler. Sorry. So it's going to be this plus this on top of it up here. Yeah, it's the two vectors added on top of each other, and the angle adds and moves clockwise around. So if we're dividing a polynomial, right, Z1 over Z2 is R1 over R2. We subtract the angles. So geographically it means that the magnitude is being divided, so it's shrinking, and the argument moves clockwise and reducing. So it's being reduced from Z1 to Z2. All right. So looking at this, I've got Z1 and I've got Z2. If I want to sketch Z1, Z2, well, first thing I need to do is multiply the modulus together. So that's going to be 2 times 3, it's going to be 6. All right. And then I'm going to add the arguments together. Argument of Z1, Z2 is pi on 6 plus pi on 2. So that's going to be pi on 6 plus 3 pi on 6. So it's 4 pi on 6. Okay. Cool. So what we have, obviously not to scale, so it's 4 pi on 6, which is equal to 120, so it's going somewhere there, and it will have 6 units in length. Yeah, 2 pi on 3. Okay. Now, let's do the next question. Really should have. Okay. Oh, sorry. Complex numbers, that should be, sorry. Sorry. So if we have Z1 and Z2, and we want to find Z1 over Z2, so that means I'm going to, this modulus is 1, and the modulus here is also 1, so 1 divided by 1 is still 1. Okay, that's not too bad. And I'm going to subtract the argument. So I've got 2 pi on 3, that's where I start first. And I'm going to subtract pi on 6, and I'm moving in a clockwise direction. So that's going to be 2 pi on, so I need, actually it's 4 pi on 6. That's pi on 6. Now this one's okay because we've actually got two positive values, so that's not too bad. So it's pi on, yeah, pi on 2. So 90. Yeah. So what we have, really, we're going to have the imaginary vector of a unit. Okay, that's the answer to that one. Okay, so I grabbed this from Maths in Focus. This is a great textbook. So this is a good visualization. So if you're going to multiply your products, your vectors, so if you're multiplying the blue vector onto the orange vector, the lengths increase, and we add the angles on top of each other. Now, if we're dividing the green from the orange, we're going to reduce it by the orange amount, yeah, and we're going to subtract the angles. So this is going to come off this angle here, yeah, or this whole angle comes off, yeah. All right. Obviously, multiplying by I. If we multiply by I, it moves clockwise in it moves by 90 degrees in a clockwise direction. If we're dividing by I, it moves if we're multiplying by I, it moves in an anti-clockwise direction. Yeah. And if it's divided by I, it's going to move it in a clockwise direction. So given that U and V are the same in length, right, we want to express U in terms of V. Well then, to get from U, well, U is really V divided by I. Yeah, because we're moving it 90 degrees in a clockwise direction. So U is equal to V divided by I. Okay, thank you very much.